Okay, you guys, here we are. We're going to start our AP Stats review for the exam. It looks like it's going to only be on FRQs, so we're going to not do any multiple choice. We're just going to focus on FRQs from here on out. All right, so here we go. So the AP test is in units, or the whole College Board thing. I'm sure you have that in your other classes too. But they're only going to be testing you on units 1 through 7 this year. And our chapters are kind of somewhat broken up into units, but it's a little confusing. So this first chapter that we did was all of Unit 1, and then there's part of the second chapter that's also in part of Unit 1, but also part of Unit 2. So, but this one's pretty good. So here we go. Let's talk about what this whole unit was all about. So this unit was all about graphs, and we had some different kinds of graphs. So to be able to make different graphs based on a table of data, or find information from graphs. So we had categorical data, which are bar graphs, and we use percentages because the counts might be different. So if you want to compare, you're looking at male versus female and you have 100 men, but you only have 20 women, well, you want to see what percent of them believe a certain thing and compare percentages. All right, dot plots. We did quite a few dot plots over the semester. It's kind of fun. We had our own things that we found, and then we created a dot plot. It's really noisy in my house today. All right, stem plots. Be able to find the 5-number summary from a stem plot. Okay, so if you had a stem plot, remember you had like 0, 1, 2, and then you had other numbers over here, 3, whatever, and you would be able to find the middle by counting off all the way till you get to the middle, things like that. Histograms, remember to choose the classes. Make sure you use at least 5. At least 5 different chunks or classes. Ogives, I'm hoping that's not on there. Nobody liked Ogives. But at the end it totaled 100%, and you just kept going like up and then up and up and up and up and up, and then it ended up being 100%. But I didn't like those either. Okay. Time plots would be a graph over time. Like, for example, here we are when the coronavirus started, and this is how much money my stocks were worth, and then over time, by the time it's just all the way down. All right, now, here we go. Be able to describe the graphs. And we use socks here, but remember, Meg, we changed this to T-socks. And what did T stand for? We need a topic sentence. Topic sentence, make sure you guys on all of these FRQs, I don't know how many there are yet. We'll find out April 3rd how many there will be, but I'm assuming it's 45-minute test. They're only going to be able to give you 3 to 4 FRQs. But make sure that you talk about whatever the context is. All right, so we had socks. Here they are: shape, outliers, center, and spread. So anytime they ask you to describe the distribution, describe a graph, don't leave any of those out. You're going to do great. So our shapes, we had symmetric, skewed right or left. Remember, don't forget to think about your crusty feet. Unimodal, bimodal, uniform, those types of words. If you forget the word bimodal, say 2 peaks, that's fine, okay? Things like that. All right, outliers. The outliers, what they could be, you're going to use a rule. We're going to talk about that in just a minute, but make sure you look to see if there's any outliers. Mean or median, you can estimate the median from a graph because it's in the middle. And then the spread is the range. You can also use IQR, standard deviation, for spread. All right, so let's talk about how we find all of these numbers. So the numerical stats, be able to find and interpret in context. That's so big, as you know. So to find the center, you can use the median. And remember, the median is the typical value. The typical value, we talk about the median household income. And the median is, of course, in the middle. And is the median resistant to outliers? Yes, it is. It's resistant to outliers. Okay, for example, if I had numbers 1, 2, 3, 4, 5, 3 is the median, but if I had numbers 1, 2, 3, 4, 10, 3 is still the median. Changing that 5 to a 10 didn't affect it. It was not pulled in that direction like the mean would. Now, the mean is the average value. The average value. And that is very much affected by outliers. So outliers can pull the mean in either direction. And I think it's so funny when you guys would come in and say, what was the mean on the test? Or what was the average on the test? But then you'd want to know the median too, because you knew that if the test had a mean or a median of 90, but the average was an 88, you knew there was some kind of an outlier pulling it in the bad direction. All right. To be able to determine which is higher, lower, or equal in different distributions. I don't know what that means, but okay, it's there. All right, the spread. Now, there's just a bunch of different ways to talk about the spread. First of all, you could talk about the IQR, which is the interquartile range. And the interquartile range is found by taking quartile 3 minus quartile 1, Q3 minus Q1. What this is the middle half of data, range. That's what that number is, the middle half of data range. The standard deviation, we use this so much this year. Let's see if you remember what it is. It's the average distance from the mean. And then the 5-number summary, remember what percent is between each. So the 5-number summary, if you remember, was min, Q1, median, Q3, and max. And so what percentage is in between all of them? Well, if you have over here, this is the min, and this is the max, and this is the median, and Q1 splits that in half, and Q3 splits that in half. Well, what does this break everything up into? Do you know? Answer it. What do you got? Good. 25% for each. Nice. Do you want me to write the last one? No, but I'm going to. I feel weird if I don't. All right. So there we go. Let's look at the rest of it. Here we go. So which of the numerical stats are resistant? So which ones are? Do you remember? We've got the IQR is a resistant measure, and also the median. Okay. Be able to determine if a new stat is resistant. So if I throw in a new, data, like, so-and-so took the test late and got a 42%. What would that do to the mean? What would that do to the median? Things like that. So it would probably pull the mean in a negative direction, because I would assuming that 42% is pretty bad. The median, it might not change that much. It might still change a little, but not that much. Be able to determine when to use which stats. So if you want to describe something, and you want to talk about its mean and standard deviation, okay, you need to make sure that there are no strong outliers or skewness. If there are, then it's kind of silly to talk about the mean and standard deviation. You'd want to go with more of the median. All right, be able to make a box plot. Of course, your calculator will do this. Choose the box plot that looks like that, because that will show you your outliers. Oh, speaking of outliers, be able to determine if points are outliers. You're going to use the 1.5 times IQR rule. Okay, what that means is you would take Q1 minus 1.5 times the IQR. Make sure you show all your work. If anything is below that number, then it's an outlier. And you would take Q3 plus 1.5 times the IQR. If anything is above that, then it's going to be a high outlier. All right, be able to determine what's going on to happen when changing a set of data, what will happen to the range, all these things. So if you're going to add, like, everybody's going to get 5 points added onto their test. Yay, that would be awesome, right? Well, that is going to change the mean, the median, the 5-number summary, okay, when you add a number. It does not change the spread, okay, the spread. It doesn't change the IQR. It doesn't change the range or the standard deviation. None of those things change. Now, multiplying, if you multiply everything, like everyone gets a 10% bonus or something, you know, you multiply everybody by 1.1 to give them that bonus, then that means everything gets multiplied. All of your stats will change. Those will change, everything. All right, be able to determine what will happen to the mean and standard deviation if another piece of data is included, a specific value. So we talked about that a little bit. Okay, and then this you can read on your own. It just summarizes everything. Let's do 2 problems. Here we go. All right, so these are kind of FRQ type problems. We're, like I said, going to skip the multiple choice stuff. So let's talk about these problems. So during the early part of the 1994 baseball season, many sports fans and baseball players noticed that the number of home runs being hit seemed to be unusually large. It's because they're all juiced up on steroids. Here are the data on the number of home runs hit by American and National League teams in order from lowest to highest. That doesn't include all of the teams, does it? I don't know how many teams there are in American League, but I don't think that includes all of them. Doesn't say. Okay. I don't know enough about baseball. If it was hockey, I'd probably know. All right, here we go. Construct an appropriate graph. I hate that. I want them to tell me to construct a box plot, construct a histogram, but they didn't. And so really, there is no wrong or right answer here. You could do a histogram and compare them, okay? But if I look down here and I know I have to find a 5-number summary, why not just find the box plot? So let's do it. Go to your calculator. I'm going to try something that I've never tried before here, which is to take a video. There we go. Look at that. Okay. Working on some stuff earlier. So go to your calculator and go to Stat, Edit. And what I did was I put in L1 and L2. Oh, hi, Mr. Motorcycle. L1 and L2. L1 is for the American League, and L2 is National League. And then I went over to Stat Plot, turn my stats on. Right now I have it set as a histogram. I'm going to change that to the box plot. Now look at, I'm using the first box plot because that's going to tell me if I have any outliers. All right, so those are on, and go to the second one, do the same thing. You can pause it if you need to input L1, L2, and all that good stuff. And then I'm going to hit zoom 9. All right, so there it is. Beautiful. Okay, I'm going to try and stop recording the video now. I don't know how to do that. Okay, so...
Well, as you can hear, I'm having some technical difficulties. I don't know what I'm doing here, so I'm going to try this one more time. And I'm going to go to hit the record button on this thing. Okay, so as you see, I went to Stat, Edit, L1, L2, went up to here, turn the plots on, make sure that you choose that one for the, so you can see the outliers, choose that one, and then hit zoom 9, and that's what your graph should look like. All right, so once you have that, you can go ahead and construct an appropriate graph for comparing. So what I would do is I would just copy it down as best as I could from the graph that you graphed on your calculator. So we'll draw a graph. Don't forget title, label, label, tick, tick, tick. So home runs for the league. So we could call our whole graph baseball for fun. And then down here, 20, 30, 40, 50, 60, 70, and 80. So you can go ahead and write those in. I'm going to try to do something else. I'm going to take a picture of the one that I already have. There we go. Use photo. Done. Okay. So I'm just going to go ahead and put mine in right there. Ha, it's done. Look at that. Okay, kind of cheated a little bit. Well, if you can't see that, that's what it should look like. And you go ahead and you can see right here that you have 2 outliers. You can see those, and you can go ahead and draw that in. So I'm just going to go ahead. Can I click on this guy? No, now he's in my way. Oh, neat. Oh, that's fun. All right, so I can't see what the rest of it is, but I know what it is. So it says for the next question. All right, I figured it out. This is a learning curve for me, right, guys? All right, so here we go. We're going to calculate now the numerical summaries. So those are in your calculator. You can either go to the graph and you can go to this graph on your calculator and hit the trace button, and it'll trace all of them for you. If you hit the arrow down, it'll arrow down to the other one to trace that one. So the National League, the American League, the 5-number summary was 35 was the min, Q1 was 49, 57.5, 68, 77. Okay, I don't think you have to label what they are because they're usually just in order. But if I was taking the AP test, I'd probably just label them just in case. And that's 29, 46, 50.5, 55, 67. So this is the min, Q1, the median, Q3, and the max. All right, so it also wants us to find the IQR, the mean, and the standard deviation. The IQR is found by taking Q3 minus Q1, so 68 minus 49. The IQR is 19. The mean you would find by going to 1var stats on your calculator, and the mean ended up being 56.9. And the standard deviation, I used X bar and S because I wasn't sure if this was the entire population, so 12.7. All right, and then for the National League, the IQR is found by doing, where is it? IQR is 55 minus 46, which is 9. The mean, when you do 1var stats again, the mean is 50.1. And the standard deviation was 11.1. All right, so here we go. Part C. Which of these numbers would be most appropriate for comparing, and explain why? I didn't answer. That's another thing. They like to pile questions into one question. I thought I was done, but obviously I wasn't. So if I were going to choose, I would probably compare the IQR and maybe the median because we have outliers. And those are resistant to those types of things. Now, the next question is, are there any outliers? Well, in our graph, we can definitely see, that there are outliers only for the National League. So we just need to check for National League. So yes, there are, but then it says to justify numerically, not graphically. I can't say, oh, they're on the graph. There they are. So we need to find out the IQR So yes for the National League only. So IQR times 1.5 is going to give us 13.5. Those outliers are low, so all we need to do is take Q1 minus 13.5. Don't forget to show your work, label what you're doing. So 46 minus 13.5 is 32.5. So anything in our data below 32.5 is an outlier. So 29 and 31 are outliers. Write a few sentences comparing the distribution. So we're going to do, T socks for both, okay? So you would start with the distribution of home runs for the two leagues, yada, 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 just keep going. Can I spell leagues? No. Okay. Is slightly different, very different, quite a bit different, okay? And then you're going to talk about the shape for each of them and how they're different. You would write complete sentences, but I'm just kind of hurrying up because it's Saturday and I want to go play. For the American League, it looks symmetric, okay? For the National League, it's skewed. And it's skewed because we have an outlier there, so it's probably skewed that direction, which means it would be skewed to the right. If you're not quite sure, don't say it. Just say it's skewed. Okay, that'll be fine. Outliers, of course, we already talked about. Hold on. Okay. The center, you would say the center, you would use the median and compare them, both of them. So 57.5 for one of them to 50.5. Their IQR, I would compare the IQRs, their spread. One was 19, one was 9, so one was, a lot more spread than the other one, more variable, things like that. Okay, so we've done that so much. I feel like you guys are going to be awesome. Now, the last one says, if the National League had existed, or the Diamondbacks had existed for the National League in 1994, because that's what our data is from, and had 51 home runs, what effect will including this operation have on the mean and standard deviation? So 51 would go in right about here. Well, guess what? Is that really going to affect this data? Look where it goes. This is in order, remember? And that's not really going to affect it that much. Yeah, that's Kyle and Jack in the background. They like to argue. So I would say that it stays about the same. Stays about the same because 51 is in the middle of the data. Middle. I know, I write like a fourth grader on here. You guys have such nice writing when you turn your homework in. And I told Greg that, because I asked one of you, like, what you use. Apple Pencil. And I told Greg, and he's so sweet, he bought me an Apple Pencil, but it's for an iPad Pro, so it doesn't work with this old clunky iPad I have. But it was literally the thought that counts. Right, Cammie? All right, number 12. A research study asked children, which of 4 different emotions they associated with the color red. What about you? Joy, happiness, love, anger. All right, the following table gives the percent of each that responded. So make a graph to display the relationship. There's a bunch of different things here, but make sure that you label, okay? So I'm going to say this is the percentage over here. Let's go ahead and 5, 10, 15, 20, 25, 30, 35, 40, okay? All the way up to there. And what I would probably do is I would just, for the females, for the males, I kind of got ahead of myself here. There we go. 26% for joy. So joy, red, I don't know. And then 27% for females. So draw that, and then I would probably color that in. And don't forget to label, this is for joy, and then this is for males, and this is females. And then you just do that with the rest of them. So happiness is 19. Oops, I'm going too far. 19, which is about here, and then 11, which is kind of small here. Okay, so that's happiness. Love was 38 for men. Okay, so this is for love, and 35 for women. Interesting. I don't know how accurate this data is. And then anger, yeah. 17 for men, so maybe about there. And then 27 for women. Okay, so you draw in your graphs. You take a look at them. Based on your graphs, compare. Same thing, T-socks. Well, not so much T-socks here, right? You just describe what you see. Okay, just use common sense. And that's going to be it for Unit 1. All right, peace out, yo.